Assalamualaikum. My name is Surah Atia Najwa, and our group will be present about case study of basement, which is for the Troika and KL CAS.
For the project background of the Troika Towers, it is located in Kuala Lumpur downtown sector and is one of the most Malaysian highest mixed-use building alongside the Ilham Tower and Petronas Twin Towers. The Troika consists of three main towers composed 229 units in total. Tower 1, 38 story, Tower 2, 44 story, and Tower 3, 55 story, which equals to 204 meters. The towers are supported by 4 basement level totaling approximately 75,000 meters square GFA. The Troika's project is anticipated to cost roughly 500 million and include glass encased sky bridge connecting the skyscrapers on the 24th floor level. Bandaraya Development Berhad proposed the Troika in 2004, but the feasibility study took up to 3 years. Construction started in 2006 and finished in 2011. Foster and Partners, which is a London-based consulting firm, designed a skyscraper in partnership with GDP Architects Sendirian Berhad of Kuala Lumpur, Malaysia. The architect and consultant worked together to create an amazing high-rise design that stood out and become one of the most iconic high-rise structures in Kuala Lumpur. The location of this building is very strategic, where it is surrounded by various facilities in all aspects such as transportation, shopping centre, hospitals, schools and many more. The Troika is well connected to many locations by Jalan Ampang, the Ampang Kuala Lumpur Elevated Highway, Jalan Tun Razak and the Smart Tunnel. This is the list of parties that involved with this project. All of the parties are from our country except the design architect, which is Foster and Partners from United Kingdom, also civil and structural engineer from Web Structures Pte Ltd from Singapore. For the Troika excavation techniques, we use the top-down excavation, which is firstly install the retaining walls, then excavate and install steel board strike, then the construction of substructure. Following, the roof slab has been built with access opening on the slab to allow work to begin downward. Next, the substructure construction, but before reaching to the top strike level backfill the soil to the level of the underground structure and remove the strike. The next is the side walls are erected vertically and the intermediate strikes are removed. The roof slabs access aperture in the chute. Lastly, backfill and superstructure construction. This process of building each level of the slab continues until the base slab is completed. The Troika Towers in Kuala Lumpur, designed by famous architect Norman Foster, contain innovative waterproofing systems that are critical to structural stability and durability of the structures. Given Kuala Lumpur's tropical rainforest climate and heavy rains, strong waterproofing techniques are required. These systems are likely to involve a number of strategies specific to different areas of the structure. For the waterproofing system at basement walls and floor, we use the high-performance waterproofing sheet membranes. At the podium and deck areas, the tower use liquid membrane. For the roof, using modified bitumen, and at the facade, using the high-quality sealant. This HVAC system is efficiently maintains temperature and air quality throughout the facility. Next, for the ventilation, the Troika Tower most likely use both natural and mechanical ventilation. Natural ventilation could be improved using architectural components such as movable windows and balconies that encourage airflow. Next, for the air filtration, This tower is anticipated to use indoor air quality IAQ sensor to monitor pollution levels such as CO2, VOCs, and particulate matter. The sensor collect data that can be used to modify ventilation rates for optimal air quality.
Second launch.
Assalamualaikum, my name is Nura Atria Najwa and I will continue the presentation with problem, solution and recommendation for the Troika. Okay, first let's look at the problems. The first problem is limited space. The Troika is located at very congested area that surrounding with many existing building which is Kuala Lumpur. Due to limited space, it's difficult in storing material, disposing of excavated material and gaining access to the site. Next problem is high groundwater level. High groundwater level has caused the high moisture and water ponding to the basement. It have a negative effect on the excavation of the basement and the overall quality of the basement structure. Last problem is difficult to excavate the basement. It is difficult to maintaining the stability of environment that is surrounding with many existing building. It also involve the excavation method and a lot of effort. Okay, let's move at the solution. The problem limited space area can be overcome by doing proper site layout planning. Effective site design help to maximize the utilization of the area that is available, ensure safety, reduce the chance for delay, and reduce disturbance during construction. Okay, next is install waterproofing system. It can help to overcome problem high groundwater level. It is important to install waterproofing system to avoid water come up to the basement. Next is using excavation support can overcome the problem difficult to excavate the basement. Excavation support utilized to reduce the amount of space required for excavation to maintain the stability of the site of deep excavation and prevent the building collapse during the excavation. Next, recommendation for improvement. The first one is to ensure that every basement is installed with waterproofing system. Waterproofing is essential for maintaining the functional of a basement and protecting the structural integrity of the building. Next is design consideration. Effective design consideration need to be taken such as waterproofing and drainage system, natural light, ventilation and others. Next is proper site preparation. Appropriate site preparation for basement building involve performing comprehensive soil testing, water table analysis, site investigation, and others. And lastly is I recommend to use temporary support. Temporary support in basement construction are employed to provide support for excavation, pre-existing structure, and prevent collapse to the building during the excavation.
Hi, Assalamualaikum. My name is Filiza and I will continue the presentation for next project that is about KL cars. First is the difficult limestone structure known as Kuala Lumpur cars has been identified by the existence of pinnacles, filters, cavities and solution channels. Such geological formations often provide difficult basement excavation, mostly because of the unknown depths on the rock head and the possibility of groundwater entry. For cast ground, second bore pile walls SBP with struts are the recommended choice. Traditionally, second bore pile walls SBP with struts are the preferred option for cast ground. This paper discusses a cost-effective and innovative alternative solution for a particular site using deep soil mixing DSM and using contiguous bore piles CBP together with the ground anchors GA. Situated in nearby areas of one of Kuala Lumpur's busiest location, the property comprises a 5,700 meter square commercial and residential complex. 4 basement levels and excavation support were required, requiring a 60 meter deep excavation through the development's 275 meter circumference. The distance from the rock head inside the site range from 6 to 90 meters. Each solution's foundation and requirements for its applicability are fully explained. There are also some design ideas and construction difficulties discussed. Comparison with design projections are provided along with the 2 retention systems excavation performance. Future development suggestions are also provided. The benefit of this strategy over other confidential strategies are emphasized. For this slide, it shows the location of the site. This image in this slide is shown the site layout plan. The project is situated in the Tun Razak Exchange (TRX) area, a premier financial district in Kuala Lumpur, Malaysia. This project involved the construction of the Exchange 106, one of the tallest skyscrapers in Southeast Asia. The site's challenging karst limestone geology necessitated innovative excavation and retention techniques to ensure stability and safety. Located strategically in TRX, this development is central to Kuala Lumpur's transformation into a global financial hub. For this slide, it shows the parties involved for the project. Client and design architect is at the same company, that is Mulia Group. For the associated architect is GDP Architects. For engineering consultant is Arup Group Consultant. And for the quantity surveyor is Davis Langdon KPK Sdn Bhd. For the main contractor is Penta Ocean Construction Corporation. And lastly, for the subcontractor is Pek Chu Group. For this slide, we will talk about the excavation techniques. First of all is open excavation. Primary technique used to handle the site's complex karstic limestone geology was open excavation. Using this strategy, the site was carefully excavated in phases down to a depth of 60 meters while continuing to be tracked to adjust to the very unstable and changing karst characteristics. To maintain the excavation's vertical sites and prevent collapse, complete retention system including diaphragms, walls and contiguous bore piles were built throughout despite the difficulties involved with the geology. Blasting technique is employed during rock excavation in order to avoid dangerous sinkholes, caves and underground streams. This method entails control blasting in order to friction the rock without inflicting much damage on surrounding structures and unnecessarily inconveniencing the society. Site information regarding the subsurface conditions are gathered prior to drilling by geologists. The second is about retention method. Shallow rock heads and contiguous bore piles (CBP), a design involving deep soil mixing (DSM) was suggested. It was suggested that one uses CBP with obtainable ground anchors in situations where DSM would not be appropriate due to deeper rock heads and or lack of space. The application of DSM was reviewed where space was available on the west and south walls. To map the rock profile at these walls, sufficient rock drilling was done. It was determined that DSM is the best use for the west wall since the rock profile was less than 10 meter and more uniform. Since the rock depth on south wall varied from 8 meter to 90 meter, it was determined that DSM would not be a good option. For water tightness issue, the DSM treatment effectively seals off the ground because the cementation fills up the voids in the soil matrix. Since the construction techniques, soil kneading was important in strengthening the excavation walls by driving steel bars and grouting them for stabilization of the slope and to prevent failures in the event of excavation slopes. Dewatering was accomplished by installing deep well points to lower groundwater levels and pumping equipment system to control groundwater levels. Open pit methods were employed in the excavation process as in similar sites. However, the actual digging was done in benches to reflect on the varying ground conditions at the site. Blasts were also used in the instance when the hard rock had to be broken to ease the digging process. That's all for me and I will pass for the next presenter.
Assalamualaikum. My name is Situna Shafika and I will continue the presentation. First, waterproofing method. They use several methods to waterproof the excavation site effectively. The primary technique includes setam bore pile, SPP wall, deep soil mixing and additional waterproofing technique. Firstly, they use SBP wall. This wall create a strong waterproof barrier around the excavation site. They prevent water from seeping in and provide crucial structural stability. Secondly, they employ DSM This process involves mixing cement with the existing soil to form soil cement column. This column stabilizes the soil and reduces the permeability, which is vital in preventing water leakage into the excavation area. Lastly, they implement additional waterproofing technique to address any potential weakness in the primary system. This includes applying waterproof membrane and sealant at critical joints. These extra measures ensure that even the smallest leaks are contained and controlled. Next is drainage system. Efficient drainage systems were crucial for managing groundwater and preventing flood. During construction, they used a temporary dewatering system with strategically placed pump and drainage canal to keep the site dry. After construction, they installed permanent drainage system, include sub-slab and perimeter drain. This system continuously manage water to prevent any build-up around the basement, ensuring long-term dryness and structural integrity. Next is the problem. They faced several challenges during the project. The geological variability of the karst formation made excavation unpredictable, with rock depth varying between 6 and 19 meters. Additionally, the high permeability of the karst limestone allows significant groundwater ingress, complicating water management. Furthermore, the urban setting in downtown Kuala Lumpur posed logistical challenges. The site was surrounded by busy streets and buildings, limiting space for the construction, operation, and storage. To address these challenges, they used a combination of SBP wall and DSM to stabilize the soil and manage water ingress. The SBP wall created a seamless barrier, while DSM reinforced the ground and reduced permeability. The first solution is dewatering system. A comprehensive dewatering system with pump and drainage canal was put in place to control groundwater level during this construction. This system keeps the site dry and safe. Second, permanent drainage. Post-construction, they install permanent drainage system to ensure the basement remain dry and structural sound. This includes sub-slab and perimeter drain. Lastly, logistical solution. They also tackle the logistical challenges by carefully planning and coordination to minimize urban disturbance. They use smaller, high-performance machinery to operate effectively in the limited space. Next, recommendation for improvement. First, enhance drainage design. Consider including redundant drainage layer and backup system to ensure continuous water evacuation. Additional drainage channel and extra sump pump can act as fail-safe. Second, cutting-edge waterproofing solution. Employ high-performance membranes and advanced sealants. Modern waterproofing material and self-healing sealant provide greater durability and flexibility, effectively accommodating the variable nature of karstic landscape. And lastly, optimizing construction process. They can use a prefabricated component and sophisticated project management software. Prefabricated increase efficiency and accuracy, while advanced software help manage all aspects of the construction process, ensuring smooth to the operation.
Okay, let me continue with the comparison between the two projects. As for seniority, the first seniority between the KL Cars and the Troika both provide the same function to the main building, which is act as parking. Next is limited space on site. Because the two projects being constructed in urban area, the main challenge that need to face is limited space during the construction. The project is required to employ complex excavation method. Next, differences. Differences between KLCAS and the Troika is for the method of excavation. KLCAS use open excavation because to address the site complicated karstic limestone geology. Meanwhile, the Troika use top-down excavation because the site location is within a constrained space between adjacent structure and others obstruction. Next, site condition. KL karst construct in a karst landscape, which is by unique geological formation such as limestone cave, underground stream, and sinkhole. Excavation procedure require attentive planning and execution to ensure stability and safety of the basement. Meanwhile, for the troika, construct in sandy silt subsoil. The construction technique that used is more difficult and require more cost.
I am Fatih Zulaika and I will be presenting the next topic, which is the comparison in effectiveness between the KL karst and the troika. First of all, the effectiveness term is giving how effective the method is, where we can see the successful outcome of the project from the best method or application used in the construction process. From the KL karst project, open cut method excavation is used, which it is more straightforward and faster to execute work. It provides easier inspection and management of the site. Moreover, it has easy access for construction workers and equipment, which facilitates a smoother construction process. As we can see from the troika, the method of excavation used is the top-down method. It is a bit less effective due to its complexity. It may lead to longer planning and preparation phases. Next, this method is quite costly since it requires specialized skill, equipment, and materials. Furthermore, the method is restricted space that it makes it quite difficult and challenging to complete the work effectively. Next, I will be sharing the efficiency between KL karst and the troika projects. Efficiency meaning is the ability to accomplish something with the least amount of wasted time, money, and competency in performance. For KL karst project, it has unforeseen subsurface condition that it leads to increased or additional expenses during its construction process. Furthermore, with its site condition that has unexpected karst features, cause the project to delay and extend. Additionally, this project's safety measures may not account for all site-specific risks. Now, for the troika project, the construction site condition able to reduce risk of costly repairs or modifications later that make it efficient. Moreover, the pre-construction surveys were made in which it may extend the initial planning but able to minimize the delays later. The troika project also provides a safety measure with detail that addresses site-specific risks comprehensively. Now, the cost analysis identified from the case study is for KL karst project. Since the open cut excavation method used for its basement excavation, it has higher preliminary costs for geotechnical assessments and stabilization measures. It also includes additional expenses for logistics and coordination for the excavation. The specialized techniques and materials required for this method in order to handle karstic condition makes it costly. For the troika project, the top-down method of excavation for basement costs roughly in RM 500 million. With its urban location and the depth of the basement in the middle of the city requires more work, with might add additional work and expenses during the construction process. The cost analysis for this project identifies logistical and urban construction challenges rather than geological instability.